Okay, how about this one? This one's got numbers, it's got dimensions, and off the top of my head, I don't know the reactions. So we're going to have to do that. So let's assume that I have a reaction at A and a reaction at B. And let's go find those. So I'm going to sum moments using my right-hand rule for sign convention. I'll sum moments about A. So my 600-pound force, does that create positive or negative moment about A? Negative, thank you. So 600 pounds. And its moment arm is 10 feet. What kind of moment is this, positive or negative? With my sign convention. Negative. So that'll be 4,000 pound-feet. And then I have the reaction that I assume By, positive or negative moment about A? Positive. And that has a moment arm of 20. So we should be able to find By. You guys have to help me with this. That's 80, 30, like 500? I don't know. Somebody help me with this. This is 6,000 plus 4,000 is 10,000. 10,000 divided by 20 is 500, right? So By is that right? Yeah, 500. Somebody check that real quick. Thank you. My Rain Man imitation is not always very good. Only on Tuesdays. Only on Tuesdays.
What is the 42 from? I didn't even ask you that.
42 is the answer that the Earth gives in Hitchhiker's Guide to the Universe.
Oh.
See, in that story, the Earth is a computer built by aliens to answer the question, what is the meaning of life? And at the very end, the Earth blows up because it's finished its calculation. And when they ask what the answer is, it's 42. So this is my standard answer whenever you ask me a question is 42. It's an interesting book. If you get a chance, you want some levity in your life.
They made a movie.
The movie wasn't bad, but like all movies, the books are usually way better than the movies. I've rarely seen a movie that was as good as the book.
There's like 5 components to the entire story, though. Like 5 books.
I know we're digressing, but a perfect example is the Lord of the Rings. There'll be a paragraph that says, and they did battle. That's 30 minutes in the movie. With a billion special effects and probably cost $20 million to make. And Tolkien, it took him 5 seconds to write it, and they battled. I don't know. For me, those things were nothing but war movies. They lost all the mystery and the fantasy. It was just battle. So I didn't really like it. I love the books. I didn't like the movies. I didn't dislike them. Some people basically worship them. I think they need to find other things to do. But anyway, let's get back to the problem. So I got AY plus BY minus 600. So I should be able to find AY now. So it looks like AY is 100. So I have my reactions. Okay, what I like to do in all these problems is I like to create myself a little template. So I'll draw some vertical lines that define the edge of the problem. Not very straight, by the way. Sorry about that. Then there's one under the point load because I know the shear is going to change. And I've got this applied couple, so I know something's going to happen in the moment diagram. So that kind of gives me a place to start. And then I'll get myself a positive x-axis and a positive axis for shear, and I'll say all my values have pounds. So let's start with the shear diagram. So I assumed AY was up, and I got a positive value of 100, so that's up. So what kind of shear is that on the left side? Positive or negative? Positive. So I should start at 100. Our rules haven't changed. We still know the change in shear is the area under the load diagram. And for the first 10 feet, what is the loading? 0. So that means I should have no change, and I should maintain 100. I also know that the slope of my shear diagram is equal to the load. What's the value of my load everywhere? In the first 10 feet? 0. So that tells me should have a 0 slope. So it looks like the shear is constant over the first 10 feet and equal to 100. Now what happens is I go from the left side of my 600-pound force to the right side. My shear changes how? Right, don't forget that change in shear is equal to the load. And that load is positive or negative? Negative. So 100 minus 600 is 500. What's the change in shear over the next 5 feet? Well, let's go up and see what's happening on the load curve. Well, nothing. So it should stay at 500. And the slope of this curve is equal to the value of the load, and the value of the load is 0. Now, what happens here? Does this affect the shear? Nope. So what's the change in the shear over the last 5 feet? Well, it's the area under the load curve, which is 0. So we still stuck here at minus 500. The slope of the curve in between is given by the load. The load is 0, so curve with 0 slope. So it looks like we get this. And this 500 matches what our shear at BY was. We said BY was 500 and up, and that's negative shear.
So it ends at 0. So does it end at 0?
No, the shear at B is minus 500. Okay, so let's now do our moment. So I'll create positive X, positive moment, and say I want my units to be in pound feet. What is the moment at A? It's a pin. 0. What is the moment at B? 0. Pretty cool. So now the change in moment is the area under the shear diagram. So here's a nice area to deal with. Let's see what it is. So the area will be, it's rectangular, so it's 100 times 10, that's 1,000. And that's a positive number, so I should go up to 1,000. And what should be the shape of this curve? Well, remember, the slope of the moment diagram is equal to the shear, and the shear is constant, positive, and 100. What happens over the next 5 feet? No. Remember, the change in moment is area in the shear diagram. What's the area in the shear diagram? It's negative. 500 times 5, that's negative 2,500. So if I start at 1,000 and I subtract 2,500, I get down to negative 1,500. What's the slope between here? Well, according to that, it's the shear. The shear is constant, negative. So here's my constant negative slope. Oops, sorry. And if we look at that value, it would be a drop of 500 to 1. Now what happens at this point, 15 feet from the left side? An applied moment. Clockwise moment creates positive change. So I'm going to take my 1,500 and I'm going to add 4,000 to it. That gives me 2,500. And then the change in moment over the last 5 feet. Area of the shear diagram. What's the area of that part of the shear diagram? Negative 2,500, which brings me back to 0. And the slope is also the same. Unfortunately, I didn't draw them exactly right, but you should see that the slopes are the same, minus 500. So now if you kind of shade it in, you can kind of see what the moment diagram looks like. What's the maximum moment in the beam? 2,500. And even though where it happens at 15 feet from the left side. All right, thanks.